All right, guys. So we talked about Pythagorean theorem in 8.2. Today we're going to talk about Pythagorean triples and the converse of Pythagorean theorem. Remember, the converse of a statement switches the hypothesis conclusion or the if and then. So we're going to kind of look at that and see what that does to our theorem. It says previously learned when two sides of a right triangle are known, the third side can be found using the Pythagorean theorem. I know we usually write that a squared plus b squared equals c squared, but the same thing would be c squared equals a squared plus b squared. Now, if you have any three, it says positive integers, so any three whole numbers where c squared equals a squared plus b squared, it's known as a Pythagorean triple, meaning we got lots of answers the other day that where c was a decimal. If they're all three end up being whole numbers, then you have a triple. And some of these can be memorized and actually save you time when you're working on these. So let's see if 3, 4, and 5 are Pythagorean triple. So the two shorter sides are going to be your a and b, and then your third side, or your biggest side, is going to be c. So if we plug them in and this works out, then we have a triple. So I say 3 squared plus 4 squared, and then I'll leave some space and put 5 squared. Now we just figure out what these two sides are. So 3 squared is 9, 4 squared is 16, you get a sum of 25. Well, 5 squared is also 25. Since they're equal, yes, we have a triple. And from now on, anytime you see that two of the sides are either 3, 4, or 5, you know the other one is the third number that we didn't use. So some other triples that you don't have here, obviously 3, 4, and 5 are going to be a triple. 5, 12, and 13 will always work, so that's another triple. So 5 squared plus 12 squared is equal to 13 squared. 8, 15, and 17 always work. And 7, 24, and 25 also work. And the thing about these is, especially the 3, 4, 5, any multiple will work as well. So 6, 8, 10, if we multiply them all by 2, that's a triple. 9, 12, and 15, and so on. So any of those would work as well. So if you see some of these in a Pythagorean theorem problem, I don't even need to see work. If you remember that, oh, well, 3 is A and 5 is C, well, 4 must be B, that's totally fine. It says, recall that given three sides, a triangle can only be formed if the sum of the smaller two sides is greater than the third. In other words, A plus B must be bigger than C. So we can use this to help us find if they're triangles or not. So let's look at this bottom one. This will lead into what we're doing later. I'm going to take the two smaller, 4 plus 5, and compare them to the longest side, 6. Well, I know that 9 is bigger than 6, so yes, we have a triangle. So we've done this before. 4 plus 5, and I'm going to compare that to 9. Well, 4 plus 5, not 9, sorry about that. Well, 4 plus 5 is 9, and that's equal to 9, so the sum of the two smaller sides is not larger, so this would not be a triangle. And then the last one, 4 plus 5 and 10. Well, 9 is less than 10, which again means we do not have a triangle. So that's all just review. That might apply to us and help us out in other ways. Next page. So now we can classify triangles by angles, and people got these mixed up with side lengths. So remember, this is angles, okay? A triangle can be acute, obtuse, or right. And remember, a Pythagorean theorem only works on right triangles, so this might be helpful. If a triangle can be formed, you can determine the type of triangle formed by comparing the square of the longest side to the sum of the squares of the shorter side. So it's basically we're going to take c squared and figure out if it's equal to, less than, or greater than a squared plus b squared. So in a right triangle, if you have one, obviously they're going to have to be equal because that's how the Pythagorean theorem works. But if you have an acute triangle, that means that c squared is less than a squared plus b squared. An obtuse triangle, c squared is greater than a squared plus b squared. So the last four problems we're going to do are just comparing these and classifying it by side lengths. But we have to do two things to do that. First, we have to determine, is it a triangle? Then we can look at the a squared plus b squared compared to c squared and tell what type. So the first one, I have 5, 12, and 4. Well, I need to pick the two smaller sides first, 5 plus 4. I need to compare them to the longest side, 12. Well, 9 is what you get from 5 plus 4, and that is less than 12, meaning that we do not have a triangle, which means we can stop because it cannot be classified. Let's look at the next one. 6, 7, and 8. So 6 plus 7 We're going to compare that to 8. Well, obviously, this one's going to work. That's 13 is greater than 8. So, yes, we do have a triangle, which means now we need to decide what type of triangle. We're going to do what we did up here, okay? So I'm going to take, it really doesn't matter what order you do it. I'm going to say 8 squared, and then I'm going to do 6 squared plus 7 squared. 8 squared is 64. 6 squared is 36. 7 squared is 49. So now I just need to figure out what that sum is, and I can tell what kind of triangle. Well, 36 plus 49 gives me 85, which means that my a squared plus b squared is greater than. So if I look up here, and the reason I did it with c squared first is because these are that way. It looks like this one right here, c squared is less than a squared plus b squared. So we have an acute triangle. Okay? Now, you might try these other two out real quick before I do it. You can pause for a second. If not, we're just going to kind of go in and do it ourselves. Classify if it is a triangle. Well, 1 plus 3 and the square root of 10. 1 plus 3 is 4, so you might need to put the square root of 10 into your calculator to see what it is. It's actually 3.16. And so, since the sum of the smaller sides is bigger, then we do have a triangle. Now we have to classify it. So I'm going to do this with the square root of 10. And remember, put it in parentheses and square it. We talked about this the other day. And then I have 1 squared plus 3 squared. Well, the square root of 10 squared is actually 10. The squared cancels out the square root. And 1 squared is 1 plus 3 squared is 9. So I have 10 and 10. Well, those are equal. So if I look back up at my list, when they're equal, we have a right triangle. Now, this one's all square roots. It's a little bit tougher. It's pretty easy to see what big and small is. So I'm going to go over here, and actually, I know that the square root of 9 is 3, and the square root of 16 is 4. So I'm going to take 3 plus 4 and compare it to the square root of 27. Well, 3 plus 4 is 7. The square root of 27, well, you know it's greater than 5 but less than 6. It's actually about 5.2 or 5.19. Well, since the sum of the smaller sides is bigger, we do have a triangle, so let's classify it. So I have the square root of 27, and I'm going to square it, and I'm going to compare that to 3 squared plus 4 squared. Well, the square root of 27 squared again, the square root sign cancels out the squared, and I get 27. I don't know why I put an equal sign there, sorry. 3 squared is 9, 4 squared is 16. So I get 27, and I get 25. Well, 27, or c squared, is bigger than 25. If I look up here, c squared is bigger than the sum of the other two squares, means it's obtuse. So that's all there is to it. Memorizing some of those triples can help you out, but it's not imperative that you do it as long as you remember the rule. Hope if you have any questions, just ask me in class tomorrow. Good luck.